Today's lecture is on the steering system of automobiles. So let us see how the steering system works and what are the different types of steering systems and the different components that are involved in the steering system of an automobile. So what is actually a steering system? So we all know that while driving cars we use a steering, and the steering of the car or any automobile is used to steer the vehicle or to move the vehicle in the desired direction. So if you want to take a turn to move to the left or to the right, or even if you want to go straight, we need to use the steering. So the steering system in an automobile is used mainly to change the direction of the vehicle, and we use the steering system to drive the vehicle through the desired path. And without the steering system, we cannot imagine an automobile without a steering system. In case of two-wheelers, we have the handle, and in case of four-wheelers and other larger automobiles, we have the steering wheel. And it provides a means for controlling the directions of the vehicle. And another important function of the steering system is to contribute, or it helps to make the automobile stable during the cornering. Cornering in the sense, cornering means while taking a turn. So usually when the automobile takes a turn, different mechanisms are involved in the steering system that we will be explaining in the coming slides. So due to that phenomenon, it contributes to the stability of the vehicle while taking a turn. Now let us see what are the functions of a perfect steering system. A perfect steering system should provide proper stability to the vehicle. It means that while the vehicle is running straight or when it is taking a turn, the vehicle should remain stable. It should not overturn or slip. It should provide a precise control of the wheel direction. That means while we are turning the steering, the wheels, the front wheels, while turning the steering, it should also turn in the same ratio, or we can say the same proportion as the steering wheel. Because when taking a turn, the driver will have a certain idea that while turning the steering wheel so much, the vehicle will also turn by this distance. So it should have a precise control on the wheel direction. Then another function of a steering system is to absorb the road shock going to the steering wheel. So we know that when the vehicle goes through the road, there are shock absorbers fitted to the axles, front axles. So when the vehicle undergoes a vibration, when the vehicle goes through rough roads, these vibrations or shocks are transmitted to other components also. So one of that component is the steering wheels or the steering mechanisms. So the steering mechanism should be able to absorb this shock. If it is not able to absorb, or if it gets damaged, then it will ruin the control of the steering system. And the last function of a perfect steering system is to prevent the wear and tear of tires. So wear and tear of tires means if the alignment of the tire is not correct, we might have noticed that when we are changing the tire or when we do a tire rotation during service, they actually do certain mechanism. They have certain mechanisms for aligning the tires, tire alignments. So that is to prevent the wear and tear of tires. If the steering system is not perfect, we can see that one portion of the tire will get worn out very easily. You can notice the tire that one side will be wearing out more and the other side will not be wearing. So that is due to certain imperfections in the steering system and in the tire alignment. So we check the tire alignment frequently to prevent this. Then the basic requirements of a steering control. What are the basic requirements of a steering control? The steering, for a good steering control, there should not be any play for the steering wheel in the straight ahead position. So no play in the sense, while we are moving our vehicle forward, even a slight turn of the steering wheel should result in slight movement of the wheels. Even if we are turning the steering wheel and if the wheels are not turning, then there is a problem with the steering control. So there should not be any play. Play means the difference between the turning of the steering wheel and turning of the actual wheel. They should be almost the same. Then second is low friction should be there, which results in high efficiency. Low friction in the sense there are different steering components and these steering components should not be having high friction. If there is high friction, it will result in wear and tear, and also proper control will not be there between the steering wheel and the vehicle wheel. So there should be low friction. Then high rigidity should be there to absorb shocks and vibrations, and readjustability should also be there, so that, as we mentioned earlier, when we are changing tires or the alignment is not correct, then we should be able to adjust the alignment. So readjustability option should also be there for a good steering control. Now, what is the basic principle of a steering system? Steering mechanism should enable a driver to maintain a straight motion of the vehicle without any huge effort, even when the bumps are encountered at high speeds. So steering mechanism, it will enable a vehicle to move forward direction. It will also enable a vehicle to take a turns in the left or the right hand direction. And it should enable the driver to change the direction of the vehicle with the minimum amount of driver effort. So we know that nowadays in vehicles we have power assisted steering system. The power steering system or the power assisted steering system, where we are providing additional power input to the manual steering system so that the steering effort becomes easy. So that will be learning in the later on slides how the power assisted steering system works. So that are the functions of a steering system, basic principles of a steering system: to maintain a straight motion of the vehicle and also to change the direction of the vehicle without any higher efforts. It should be easy. One of the common systems, steering systems, that was used very earlier, it is a very theoretical system, that is known as a swinging beam system. So in a swinging beam system, we have a frame, the vehicle frame. This is the frame, and this frame at the front side, it is mounted on a turntable, on which the wheels are fixed. So this turntable can rotate in either direction, to the left or to the right, and when the wheels are fixed to this turntable, these wheels can also rotate to the left or to the right side. And one important feature of the swinging beam system is that both the front tires will be aligned in the same angle, or they are aligned at the same angle. Here you can see, if we are drawing a line, an imaginary line through the center of both the wheels, it will be passing through the same axis. So this is the line. If we are extending this line, it will pass through the center of both the wheels, and both these wheels are aligned at an angle of 90 degree to this line. And if you are extending this line and if you are drawing another line, imaginary line passing through the center of the rear wheel, the back wheel, both these lines will be intersecting at a point, an imaginary point known as LC. So at this point you can see this is the center point around which the vehicle will turn. So this will be the radius and this will be the center, and the vehicle will be turning around an angle. So this is the characteristic of the swinging beam system, that both the front tires will be aligned at the same angle, that is 90° with the imaginary line. And if you are drawing an arc, you can see that the direction of the tires will be acting as a tangent to this arc. So if the vehicle is undergoing a circular motion, you can see that the front tires, both these front tires will be moving in the direction of motion will be a tangential one. Similarly here also, if you are drawing an arc, the motion of the rear wheel will be tangential. So that is the swinging beam system. It is a theoretical system. A swinging axle beam is mounted on a turntable on the vehicle frame. It turns the wheels and allows the vehicle to move around an imaginary center LC. All wheels are at right angles to the radial lines drawn from LC. That is, all the wheels are at 90°. If you are drawing a line from LC through here and also through here, you can see that both the angles are 90°. The natural tendency of a wheel is to travel in a straight line, so curved path will cause greater tire wear. So in this case, you can see that both these tires are at the same angle, but you can see that while undergoing a turning motion, the inside or the inner wheel and the outer wheels, the velocities should be different. The inner radius or the inner distance is smaller when the vehicle is undergoing a turn. The inner tire, that is this tire, has to move only through a small distance, whereas the outer tire should move through, or it should cover a larger distance. So both the velocities will be different, and if we are using such a system, it will cause slipping to occur, and therefore there will be tire wear. Tire wear can be kept to a minimum if the wheels are accurately aligned. If the alignment is proper, then we can minimize the wear and tear of the vehicle. But in this system, chances of slipping is more because both these tires are moving through the same angle, or they are aligned at the same angle. So we can see why the slipping occurs. Another important system which is used very commonly in automobiles for steering is the Ackermann steering system, or the Ackermann layout. So you might have learned about the Ackermann steering wheel mechanism when you studied the linkages, the 4-bar linkage or the 4-bar chain. So Ackermann steering system is an example of a 4-bar chain. So you can see that the major difference between the swinging beam system and the Ackermann steering wheel mechanism is that the front wheels are aligned at different angles. Earlier in swinging beam system, we know that both the front tires are aligned at an angle of 90°, whereas in Ackermann layout, both the front wheels are aligned at different angles. You can see here one angle is A, angle of one tire is A, and angle of another tire is B. The second feature is that if we are drawing a perpendicular line, imaginary perpendicular line through the center of both these wheels, these two imaginary lines will come and meet at a point LC when we are drawing a similar perpendicular line from the rear wheel also. So all these three lines, that is the line passing through the center of the rear wheels and the lines passing through the center of the front wheels, will be intersecting at a point known as LC. Again, this is the center point through which the vehicle will rotate. But here the angles at which the tires are aligned are different. One angle is A and the other angle is B. So why do we need to keep both these angles differently? That is explained by the Ackermann system. So only if these tires are aligned at different angles, the vehicle will undergo a turn correctly. So this Ackermann system allows different steering angles at each wheel which is taking a turn. And the inner wheel should turn at a greater angle than the outer wheel, because the inner wheel has a smaller turning radius. It should turn through a smaller angle, whereas the outer wheel has to cover a more distance and therefore it has a longer turning path. So the Ackermann layout allows inner and outer wheels to follow different paths during the turn, and it allows the vehicle to follow the ideal path while the vehicle is undergoing a turn. So let us see a video of how the Ackermann system works. You can see here that a vehicle is undergoing a turn through a curved road. So this is the path that is to be followed by the wheels. This is the inner wheel and it is undergoing a smaller radius, whereas the outer wheel has to cover more distance and it is undergoing a larger radius. So while the vehicle is moving or it is turning, you can see for the vehicle to move correctly along this path, you can notice the difference between the angles of the inner wheel and the outer wheel. Both are turning at a different angle. So this inner wheel has to be rotated or it has to turn through a greater angle so that it can undergo this turning correctly. So while making a turn, these are the forces that are acting on the wheel. So when the wheel is rotating, we have different forces that are acting while the wheel is going in the forward direction. We have the top rotational velocity that is tangential to the rotation of the wheel, and we also have the bottom rotational velocity which is acting tangentially but just in the opposite direction of the movement of the vehicle. So there are two different velocities, top rotational velocity and bottom rotational velocity. And in addition, there is a translational velocity component that is also acting in the direction of movement of the vehicle. So in total there are three different velocities: top rotational velocity, bottom rotational velocity and translational velocity. So these three are the different components of velocity when the tire is rotating and the vehicle is moving forward. So when the vehicle is moving, the bottom rotational velocity and the translational velocity, they should add to a value equal to 0 for the proper movement of the vehicle. When the vehicle is undergoing a turn or when the tire is turning, you can see two different cases. One case where the rotational velocity is acting opposite to the direction of rotation of the tire, and the translational velocity is in the direction of motion of the vehicle. You can see the vehicle is moving forward, so translation velocity direction is this side and the rotational velocity is going just perpendicular to the motion of the rotation of the tire. So in this case, the vehicle will move forward. That means even if the tire is turned, the vehicle will move forward. That means the vehicle will undergo slipping. So in order to avoid slipping, the translational velocity direction should be just opposite to the rotational velocity. If both these velocities are in the same direction, then the vehicle will undergo a turn without slipping. So that is the condition, that the translational velocity and the bottom rotational velocity both should be in the opposite direction. So as we mentioned earlier, if we are considering imaginary lines from the center of both these wheels and the center of the rear wheel, it will be coming and meeting at an imaginary point, and that will be the center of rotation of the vehicle. So that is the principle of the Ackermann layout, or the Ackermann steering gear mechanism. Now, the two different terms that can be associated are the track width and the wheelbase length. The track width means the width between the tires, the center of the tires, and the wheelbase means the distance between the center to center distance between the front wheel and the rear wheel. So this is the wheelbase and this is the track width. So the values of track width and wheelbase will also affect the turning of the vehicle. That means they will affect the angles of the wheels while the vehicle is undergoing turning. So there should be a definite ratio between T and W, that is the track width and the wheelbase. Now let us look at the different common parts of the steering system. So in a steering system, we have an axle beam, which is a fixed component, an axle beam which is commonly having a I section component in order to reduce weight and increase the rigidity. So this axle beam will always have an I section. And we have spring seats where we load or we clamp the spring of the suspension system. And we have the stub axle, and the stub axle is the component where we actually put the wheels on, or the wheels are clamped to the stub axle. And we have the track rod or the tie rod. It is also known as the tie rod, track rod or the tie rod, which helps in the steering mechanisms. So this track rod and the track rod arm is joined with the track rod at this point and is known as the track rod end joint. There are two track rod end joints and we have two track rod arms on both the sides. So this track rod arm and track rod will help in turning the stub axle through the desired angle. And the stub axle at both the ends, they are pivoted at a pin joint, and this pin joint is known as the kingpin. The kingpin, it is actually a pin joint or a pivot, and the stub axle can rotate or it can turn through an angle about this axis. So both the stub axles at both the ends, they can turn through the kingpin. So this is the kingpin. And we have the steering column. So we have the steering wheel at the top, and then we have the steering column drive shaft or the steering column, and then we have the steering gearbox. It is a gearbox assembly, and we have a drop arm which is fixed. One end is fixed to the steering gearbox and other end is connected with a drag link. This is a link, and the drag link is connected to a drag link arm through a joint known as a drag link joint, and this drag link joint is actually used to pivot one end of the stub axle. So while turning one end of the stub axle, suppose you see that when we are turning this stub axle through a small angle, suppose it is turned this side, So it will pull, or the track rod arm at this point, it will pull the track rod in this direction. So it will move in this direction. And so that since all these components are joined by pin joints, the movement will be transmitted from the track rod and through the track rod arm to the second stub axle, and the stub axle will also be turning through the same angle. So it will be turning like this. So if the vehicle is undergoing a turn to this direction, so this wheel, suppose we have the wheels that are clamped or that are mounted on the stub axle. When the steering is rotated, the steering box, the gear mechanisms will operate, and it will pull the drop arm so that the drag link is pulled to one direction, and it will pull the drag link arm, and also it will turn this stub axle by a small angle. So now the stub axle direction will be like this. So it is turned through a small angle. Similarly, the stub axle at this point, it will be like this, in this direction. So it is turned through a small angle like this. So what angle is turned by the stub axle at this point? The same movement is transmitted to the stub axle at this point also. But since the movement of track rod is also there, as we know, the angle through which the wheels turn will be different, slightly different. So if the vehicle is turning through this direction, suppose the road is like this and the vehicle has to move in this curved path, then this wheel has to be turned at a larger angle, and this wheel has to be turned at a smaller angle that we saw. So the inner wheel, in this case, this is the inner wheel and this is the outer wheel. So the inner wheel will be rotated at a larger angle and the outer wheel will be rotated at a smaller angle, so that the vehicle will undergo the turn smoothly. And when the vehicle is undergoing a turn in the other direction, suppose the vehicle has to move in the curve on the other direction, the stub axle again, after the steering is turned, stub axle will move to this direction, so that the vehicle will move, the wheel is turned in this direction, and also this stub axle is will be moving to a new place here, or it will be turned through a new angle here, so that the wheel is also turned like that. So now the wheel situated at this stub axle will become the inner wheel, and the wheel at this stub axle will become the outer wheel. And the inner wheel or this wheel will be rotated at a larger angle, and this wheel will be rotated at a smaller angle, so that the vehicle will undergo a turn like this. Each wheel hub is mounted on the stub axle. So wheel hub, we have the wheel hub here, and wheel hub is mounted on the stub axle, and it will swivel or turn on the kingpin or the ball joint. So this is the kingpin or the ball joint, and this stub axle can move to either direction, to this side or to this side, because this is a pin joint. The linkage connecting the two stub axles together comprises of a track rod. So this is the track rod arm, and this is the track rod, also known as the tie rod. So this tie rod is responsible for transmitting the motion from one stub axle to the other. The layout is obtained by positioning the track rod on an imaginary line. So here, if we can check two different arrangements, one in which the track rod is coming at the front side of the system, and the other in which the track rod is coming to the back side of the system. So this picture shown here, it shows that this is the forward direction in which the vehicle is moving, and the track rod is located at the back side of the system. That means this is the arrangement where we have the kingpin here, that is the kingpin that is shown here, and the track rod is coming to the back side. So this arrangement is being shown here. So in this case, the arrangement should be such that if we are drawing imaginary lines starting from the center of the kingpin, the line should pass through the track rod end joint. So this joint is being shown here. So this line should pass through the end joint such that these lines will be intersecting at a point. So if this is the arrangement, then you can see that the system is correctly aligned. So this is the case where we have the track rod located at the rear side or the back side of the axle beam. This is the axle beam. Track rod is located at the back side. The another arrangement is where we can see the track rod is located in the front and we have the axle beam located at the back side. So that means this whole component will be coming at the front. It will be coming like this. In this case, the track rod or the tie rod should be longer so that when we are drawing a line through the kingpin, it will pass through the joint, track rod end joint also. So this line, this particular imaginary line, it should pass through the kingpin and also the track rod end joint. Again, in the previous case, similar to the previous case, these two lines will be coming and meeting at a point, center point. So these two are the two different cases. The first case where the track rod is located at the rear side. In that case, the track rod should be lower or it should be lesser in length when compared to the axle beam. And the second case where the track rod is located on the front side of the axle beam. In that case, the length of the track rod should be longer than that of the axle beam. So that are the two different positions. So these two are the different diagrams which shows, the first figure shows that there is no Ackermann system. So this is similar to the fixed beam system where both the wheels turn through the same angle. Suppose we are turning the steering wheel, this wheel stub is turning through an angle of 30 degree, then this will also turn through an angle of 30 degree. Second case is Ackermann layout where when we are turning the steering to the right hand side, the right hand wheel undergoes a turning of 30 degree whereas the left hand wheel is undergoing a turn of only 23 degree. You can see that these two angles are different. So when the vehicle is turned like this, that means when the steering wheel is turned to the right hand side, which means the vehicle is going to turn to the right hand side, this will be the inner wheel and this will be the outer wheel. So the inner wheel has to be turned at a larger angle than the outer wheel. That is the principle of Ackermann layout. So the Ackermann layout, if you are considering the linkages, suppose this is the linkage A, B, C and D, the Ackermann linkage system. When the vehicle is running in the forward direction, that means it is not undergoing any turn, the links AB and CD, these two links will be parallel to each other. When the vehicle is undergoing a turn to the left hand side, you can see that the wheel on the left hand side is turning through an angle of theta and the wheel at the right hand side is, suppose it is turning through an angle of phi, and we are drawing imaginary lines. It will be coming and meeting at a point, say L, an imaginary point L, through which we can also draw a line which passes through the center of the rear wheel. So you can see the difference in angles theta and phi. Now let us just see the mechanism of Ackermann steering, how the turning of wheels takes place, it will give you a clear idea of how the Ackermann mechanism works. So this is a lab equipment which shows, or the lab setup which shows Ackermann steering mechanism. So this is the steering column. This is supposed to be the steering column, and it is moving the wheels, and these two joints, the two joints located here. So this joint, pin joint, and this pin joint. In actual practice, these two pin joints around which the wheel is turning, they are known as the kingpin. Kingpin is the pin joint or the swivel joint about which the stub axle will turn. Stub axle is the axle where we mount the wheel hub and the wheel. So let us see how the operation takes place. We can see here, while it is undergoing a turn, suppose now the wheel is undergoing a turn, or the vehicle is undergoing a turn to the left hand side. The inner wheel or the left hand side wheel is undergoing a larger turning angle. Suppose this is the horizontal, so this is the vertical. So this is an angle alpha. So this alpha will be greater than the angle that is being executed or that is covered by the outer tire or the external tire. Let us say it is beta. So always alpha will be greater than beta. So that is the condition of Ackermann steering mechanism. And when the wheel is turning to the right hand side, again the same case, this will become the inner wheel and this will become the outer wheel. Inner wheel will be turning at a larger angle than the outer wheel. That is Ackermann steering mechanism. Now let us define certain terms that are associated with tires, the steering system. Slip angle. Now slip angle means if a side force, you can see a side force, if it is acting on the circumference of the wheel, it will cause the tire to deflect along a certain path. Suppose normally if the tire is taking a path A, due to the side force and due to the deflection that is caused by the side force, there will be a slight deviation. Say the tire is now going along the path B. So the difference in angle or the angle between these two paths A and B is known as the slip angle. That means the vehicle, instead of going through the path A, is now going through a path B, or it means, in other words, slight slipping is occurring along this path. The adhesion or the grip is eventually lost and the tire starts to slide sideways. So it is, in other words, we say that it is slipping. And the another ratio, that is cornering power, it is a ratio that is given by the ratio of side force, which is expressed in newtons, divided by the slip angle in degrees. And the cornering power of a tire, it is controlled by certain conditions, that is inflation pressure, that is the pressure at which the tire is inflated. So as the pressure increases, it raises the cornering power. Tire construction, how the tire is constructed, we have different ply systems, or the way in which the different layers of the tires are arranged. Ply means it is one layer of the tire. So we have multiple plies or multiple layers which make up an entire tire. So if the plies or the different layers are arranged radially, it is known as a radial tire. If it is arranged in a crosswise direction, that is one ply is kept and on the top of that ply or layer another layer is kept in the cross direction, it is known as a cross ply tire. So a radial ply tire has a greater cornering power than a cross ply tire. Then tire size also influences cornering power. A low profile tire has a smaller width or a smaller wall, so higher cornering power is achieved. Then the wheels are tilted by a small angle. I'll tell you the reason why it is tilted when we come to camber. So camber or tilting the wheel from away from the side force increases the cornering power. Also, the load on the wheel again influences cornering power. If the load is varied from the normal, then cornering power will decrease. So all these are the different factors which affect the cornering power or the ability of a tire to undergo a turn, that is known as cornering power. Self-aligning torque. So self-aligning torque means that when a tire is acted on by a side force, the tire wall or the side of the tire deflects by a small angle, and that is known as the slip angle. So during this condition, the side deflection of the tire is greater where the tire leaves the road as it rotates. So during slipping, one portion of the tire will lose the contact with the road. So that is where the deflection is more. And due to this, it produces a self-aligning torque, which attempts to turn the wheel to align itself with the actual direction that the wheel is taking. That means even though a slight slipping chances occurs, it will produce a self-aligning torque which will help in bringing the wheel back to the normal position. Now coming to a term known as oversteering. Oversteering means when the vehicle is rotating more than the usual condition, or when the vehicle undergoes a turn more than we are expecting while doing the steering operation. When the rear slip angles are greater than the front slip angles, the vehicle will turn more sharply than the normal condition, that is known as oversteer. So in order to avoid or to correct oversteering, the driver has to straighten up or bring the steering wheel to the normal position soon. That is by effectively reducing the cornering angle by turning the front wheels in the direction of the rear wheel oversteer. So that has to be done manually by the driver himself. And what can cause oversteering? That is, the center of gravity is moving towards the back side. That is, load is increasing to the back end of the vehicle. Then lower inflation pressure for the tires at the back side than recommended. So that means if the tire pressure is lower at the rear or the back tires, it can also cause oversteering. Then large load is being transferred from the inner rear wheel to the outer rear wheel when it is undergoing a turning operation. So all this can cause oversteering. Oversteering, as we know, it can be dangerous. That means if the driver is not very experienced, then this oversteering cannot be controlled and the vehicle will overturn. So the vehicle designs will try to avoid any oversteering tendencies wherever it is possible. So this diagram shows the angles through which the vehicle will turn when undergoing an oversteering operation. Now understeering. Understeering is just the opposite of oversteering. That means when we are turning the steering at a particular angle, and if the vehicle is not turning as we have expected, then it is known as understeering. So understeering is produced when the front slip angles are greater than the rear slip angles, and it will cause the front of the vehicle to move away from the side force, and it will cause the vehicle to take a path of larger turning radius. That means the vehicle will not turn very easily, it takes more time to turn. So that is known as understeering. So a reasonable amount of understeering is okay, it is fine, but if it is more than what is expected, the steering of the vehicle becomes difficult and accidents may occur due to understeer. Now let us see what are the different steering mechanisms that are widely used. Steering mechanism is actually the mechanism which links the steering wheel to the wheels that are running on the road. So there are a number of components that are involved in the complete steering mechanism. Two types of steering mechanisms are commonly used. One is the rack and pinion mechanism, which is almost used for almost all the cars. And we also have the steering box mechanism, which was mainly used with light commercial vehicles and trucks. And now, since we have the rack and pinion mechanism, it is confined to larger vehicles. So the most commonly used steering mechanism for lighter vehicles is rack and pinion steering mechanism. So let us see what is the rack and pinion steering mechanism. We have the steering wheel here, and we have a steering column which is known as a telescopic type steering column because of its shape, and it has a vibration or which has a damping capacity or vibration absorbing capacity. The impacts are absorbed by the steering column, and we have a linkage which links the steering to the steering box mechanism, where we have the rack and the pinion gears which are mounted or which are in contact with each other. So we have the flat gear or the rack, and we have the pinion or the worm gear or the pinion gear. So this pinion gear will be rotating about, or it will be engaging with the rack gear. So when the steering is turning to the left hand side, the pinion will also move to the left hand side, and it will cause the rack to move or shift to the right hand side, or the pinion will be moving, so the rack will be moving to this side. When the pinion is turning or undergoing a turning in this direction, it will rotate and turn the rack to the left hand side. That is how it operates. And this rack and pinion arrangement is connected to the stub axle. This is the stub axle. These two are the stub axles, and this is the kingpin. The kingpins are located here, and this is the tie rod. So in this case, the tie rod mechanism is slightly different from the earlier mechanism which we saw. Tie rod or the track rod joint is this. This is the joint. These two are the track rod joints, and these track rod joints are connected with the stub axles. So when the tie rod, this is the rack and pinion mechanism. When the pinion moves, it will push the track rod so that it will turn the stub axle through an angle. So when the stub axle is turning through an angle, it will pull the track rod so that again the movement is transmitted to the other end of the other side of the track rod, and also to the other side of the stub axle or the other stub axle. So this stub axle will also be turning through a small angle. So any movement that is occurring at this stub axle portion will be transmitted to the other stub axle portion through the track rod mechanism. So the earlier mechanism which we saw, we have the axle, the fixed axle, and we have the stub axle on which we have the wheel hub and the wheel that is mounted, and we have the track rod or the tie rod, and the tie rod joint is there, and this is known as the kingpin and the front hub assembly. We have two kingpins here, and this is the steering wheel, and this is the steering column, and we have the steering box here. And steering box contains a set of gears, or it can be a cam and roller steering box mechanism also, and it will turn or it will move the drop arm through an angle. If you are turning the steering wheel, through a particular angle, the drop arm will also be moving through certain distance, so that the drag link will also move in a proportionate distance, and it will turn the stub axles also in a particular angle. Now the steering geometry. Steering geometry is a term used to describe the steering and the wheel alignment. So how the steering wheel and the actual wheel of the vehicle are aligned together is described by the steering geometry. So improper steering geometry will cause difficulty in steering, and it will again cause instability to the front side of the vehicle, and it will cause the tire wear easily, and also increase the shocks from the road. So that all these are the different phenomena that will occur due to improper steering geometry. Now steering alignment, in which the components are placed at the right position to maintain assembly balance. So the vehicle should have a correct steering alignment so that the components are placed at the right position to maintain an assembly balance, and it will ensure safety and the proper operation of the vehicle. Now important factors which help in correct steering alignment are caster, camber, and toe in and toe out. So these are very important factors which you should remember. So you will see in detail what these important factors are.